2167, minimum time to remove all cars containing illegal goods. So let me explain the question. So yeah, the description is very long, but actually it is really easy to understand. What we need to do, we are giving a string which includes 1 and 0. So inside we can only remove 1. Yeah, we can only remove 0 or 1 at the left side or right side. But what we need to do, we only need to count how many removals. If we remove from the left side, if we remove a 1, yeah, we're gonna count as 1. If we remove those ones, we're gonna count as 2. Yeah, but we remove a number in the middle. Yeah, for example, this one. Yeah, if we want to remove a number in the middle, we're gonna count it as 2. If we remove this one, we're gonna count it as 2. And these two ones, we're gonna also count it as 2. So 2 plus 2 and plus another one. So for the last one, yeah, we can remove this 1 directly. Yeah, also for this one, we can remove those 1 and 0 directly and then remove the last one. So it's gonna be the same. So in total, it's gonna be 5 times. Yeah. If you understand the process, now we can try to find a solution to solve it. Yeah. If we remove from both sides, like from the left side or right side, we also need to consider if we can remove from the middle. That's gonna be really difficult. Yeah. So the idea is we're gonna separate the array. We're gonna separate the string. So for example, if we can separate the string like that from the left side and the right side, yeah. First of all, we have a string, and then we're gonna separate. But how to separate? We can enumerate from 1, 1. Yeah, we can enumerate using the index. Yeah, from 0 to n-1. So for example, the string will be enumerated like 1 with the last, or 110, 0 with 101. Yeah, it's gonna be separated to 2 parts. Yeah, for each of the part, we can use the prefix sum to solve the problem. Yeah, for the left part, we can use the prefix sum. Why? Because for this number, if it is 1, we're gonna, yeah, if it is a 1, we're gonna have 2 solutions. It's gonna be the minimum of the 2 solutions. First of all, we can remove this 1 directly because it is at the left side. It's gonna count as 1. Or we can remove this 1 just in the middle. We can imagine this one, maybe it is just in the middle. We're gonna count it as 2. Yeah, and for all other cases, for example, there is another one. If we want to remove this one, what are we gonna do? We're gonna take the minimum of, yeah, like if we remove 1101, it's gonna be called 4 times. Or we can remove this one directly. If we remove this one directly, it will always depend on the previous part. Yeah. So for example, the previous part, this is according to DP, this is 1 and this is 1. It means from here it is 2, and here is 0. It means up to this point we consumed 2 times, and for this one it's gonna be 4. Yeah, if we count from left to right to this one, it is 4. If we remove this one directly, it is also 4, because from here it is 2. 2 plus 2, it is 4. Yeah, so let me give you another example. So for here, if we remove 1 by 1 from the left side up to this one, we're gonna consume 5 times. Or we can remove this one directly in the middle. It consumes 2 times. Yeah, but we need to check the previous part. For the previous part, at this 0, it is 2. So 2 plus 2, it is 4. 4 is less than 5. So this is why, according to DP, we're gonna choose the minimum. Yeah, so this is the prefix sum. And similarly, we can calculate the suffix sum. Yeah, we're gonna calculate the suffix sum like the same way. Yeah. But while we are preparing the prefix or the suffix, it would be the same, exactly the same. First of all, we're gonna enumerate from the left to the right. We prepare the prefix sum, and then we're gonna prepare from the right to the left. Also, it's the suffix sum. After that, we can enumerate one by one to check the result. So the result will be the minimum of all the enumerations. Yeah, let me just start the coding. So we're gonna prepare n would be less of the string, and then I'm gonna prepare two array, prefix and suffix would be equal to 0 times n plus 1 and 0 times n plus 1. Yeah, now we're gonna prepare the prefix array. So for I in range 1 to, let me check, and the prefix array is gonna be from 1 to n plus 1. Yeah, because it will go to, for the prefix array, it will start from index 1 to index n. Yeah, so we're gonna check if si equals to 1. This means we're gonna check the minimum of the result, so the prefix. And here, because our prefix array there is a padding 0, it means for the s string it's gonna be I minus 1, and from here it's gonna be the prefix I should be equal to the minimum of there are two solutions, there are two ways. So one way is prefix I minus 1 plus 2, because we remove it in the middle, and another way is from the left side until to this I, so it's gonna be I. Yeah, let's just try an example. Let's try the first one. Yeah, for this one, so the I equals to 1 and si s0 equals to 1, and prefix 1 should equal to the minimum of prefix 0. Prefix 0 is 0, 0 plus 2 it is 2, but this I is 1. So the minimum is 1. It means if we were to remove this one, we're gonna consume 1 time. Yeah, it means this is right. Otherwise, if it is equal to 0, so the prefix I would equal to prefix I minus 1. Yeah, so this is the prefix. Now let me just copy it and prefix the suffix array. So for the suffix array, it's gonna start from the right to the left side. Yeah. Similarly, we're gonna have a padding. From the right side, the first one is padding. Yeah. So we're gonna start from n minus 1. Yeah, because I equals to n is the padding, and until to 0. Yeah. So we're gonna check if so si, the first one should be sn minus 1. So if si equals to 1, yeah, we just need to replace it to suffix. Yeah, and here should be I plus 1, and here also I plus 1, and this gonna be the suffix. Yeah, so if we find a 1 from the right to the left side, we're gonna check the minimum of suffix I plus 1. Yeah, I plus 1 plus a 2. And here we're gonna change it to n minus I. Yeah, let's just check an example maybe. Let's check the right side, check this one. So for this one, yeah, so the n minus 1 is this I. Let's check 0, 1, 2, 3, 4, 5, 6. It is 6. So here s6 equals to 1. If it is equal to 1, so the suffix 6 should be the minimum of a suffix 7, and we prepare a padding. So the suffix 7 would be 0 plus 2, it is 2. And here this n is 7, 7 plus 6, it is 1. So the result would be 1, it means it is right. Yeah. Now we just need to return the final result. So the final result is the minimum of AB, so for this AB in zip, prefix and suffix. Yeah, because we prepared this prefix and suffix, and we just need to enumerate it. Yeah, we're gonna enumerate all the possible results. We just check the minimum, because here should be A plus B. Yeah, A plus B means the minimum from the left and the right side. Yeah. Now let me just run it to check if it works. yeah, let me check what is wrong. Okay, only concatenate to string, not int to string. It means something is wrong. Let me let me check why. So I did a typo. I think it is a typo. It should be the prefix. Now let me run it. No, at least it is running, but I didn't get the right result. Let me just check it. Let me print out the prefix and suffix. Prefix and suffix array. Oh, everything inside is 0. It means my function is totally wrong. If it is equal to 1, here is should be equal, not double equal. That is why there is also a typo. Now let me run it. As you can see, it works. Now let's check the prefix and suffix array. So at each of the position, for example, the position at 0 means from the right side there's a 0, from the left side there's a 0 element. But from the right side that is all the elements. So we're gonna check how many operations. So that is 0 plus 7, it is 7. Maybe from here. So for example, from the left side it means there are 2 operations. From the right side there's 3 operations. So in total it's gonna be 5, and this 5 gonna be the minimum. That is why we're gonna enumerate all the possible results. Because you cannot solve it directly from the left to right. So you have to solve it from the left to right and from the right to the left, and then you're gonna enumerate all the possible results. Because the time complexity would still be O(n). Because before that you prepare a prefix and suffix array, and after that you can use this prefix and suffix to get the